So hello students, today we'll continue again with our unit number 1 and topic number 6, which is different types of formwork based on structural member and technical and functional requirements of formwork. In our last class we studied about different types of formwork based on material, and today we'll study about based on the structural member. So different types of formwork based on structural member. Number 1, beam formwork. So, beam formwork consists of pre-assembled form sheeting parts, as you can see in the picture here. It is a method for covering straps is used for nailing of sheeting boards together for providing sheeting base and side panels. So the extent of work is dependent upon the width and thickness of sheeting base and cover straps and the width of truss board. A whaler is mounted at the upper edge of side sheeting to hold together the forms by wire ties. The whaler and segments are propped by diagonal sheets. Number 2, column formwork. The sheeting of column formwork is prefabricated depending upon the required column dimensions. Steel bolts are used to anchor the sheeting panels in foot rim. Vertical arc timbers are placed to take the forces from cover straps of formwork sheeting. The diagonal board braces are used to tie the column in formwork laterally. 3. Wall formwork. Wall shuttering consists of vertically arranged upright formwork bearers, and sheeting boards are nailed to it at concrete site. Moreover, upright timbers are braced diagonally by using boards at both sides. The opposite whalers must be tied at specific distances, and cleaning holes are to be located at the foot of the formwork. 4. Foundation formwork. Foundation formwork are designed differently for different foundation types and sizes. So formwork specifications will be different for isolated and strip foundation. The design of formwork is mainly dependent on size and depth of foundation. Metal screws and tie wires are used as formwork ties, and generally sheeting panels are used along with formwork bearers for foundation formwork. Here is a picture of foundation formwork. Next, slab formwork. System of ceiling shuttering provides ease in transport, assembling and stocking. So ceiling formwork has optimum stability and time is saved while assembling and disassembling. The basic elements of ceiling shuttering are wooden beams and steel supports, and it doesn't require much expertise. The next topic is technical requirements of good formwork. 1. Formwork should be exactly designed of the required shape and size so that it fits at the designed position. 2. According to the desired concrete surface, the material of the formwork will be selected. 3. Formwork should be strong enough to withstand the pressure of fresh concrete and working loads, and should not distort or deflect from their position during the concrete placing operation. 4. Formwork should support the design horizontal and vertical loads. It should also support the other unusual loads also during the construction period. 5. The formwork should not disturb the structure or concrete surface during the removal time. And the last one, the segments of the formwork should be tightly fitted to minimize the gaps between them, which prevents the leakage of cement material. Here I have shown a table of structure member with its ordinary Portland cement days and rapid hardening cement. So this structural member takes this much time of days depending on the cement. If you for beam sides, walls and columns, if you use OPC, that is ordinary Portland cement, it will take 2 to 3 days, and for rapid hardening it will take 2 days. For slab, vertical support, 4 days and 3 days. For slab complete formwork removal, OPC 10 days and rapid hardening cement 5 days. Beams, where removal of sheeting props remains intact, OPC 8 days and rapid hardening cement 5 days. Beams and arches, complete formwork removal up to 6 meters span, OPC 14 days and rapid hardening cement 5 to 8 days. Beams and arches on complete formwork removal up to more than 6 meters span. OPC is 21 days and rapid hardening cement is 8 to 10 days. Next topic, functional requirements of formwork. Number 1, form segments should be of suitable size so that they can be transported and stored easily and reused at another place. Number 2, formwork should be easy to dismantle and fit so that construction or building process advances. Number 3, formwork segments should have symmetry so that they can be interchangeable and can be used at different places. Number 4, forms should be simple to build. Number 5, formwork should be lightweight but with enough strength required to withstand the loads and pressures. Number 6, forms should be made such that workers can handle them without any safety issues, respecting the health, safety and hygiene regulation in effect. Next topic, basics of staging. So staging means that portion which supports centering and shuttering, and this can be done by using wooden bellies, pipes, props or jacks, H-frames and space frames using coupler or cup lock system. So now we'll go through to videos. You can give your attendance in the chat box along with your name and enrollment ID. Thank you.
Civil engineering. The mold made up from some rigid materials like timber or steel plates in which concrete is placed and in which it hardens are called as the formwork. When the fresh concrete is placed for the construction purpose, it is in plastic state. Therefore, it is more essential to provide a temporary structures to support a fresh concrete till it obtain a required and sufficient strength. These temporary structures provide to a fresh concrete is called as the shuttering or formwork. Formwork is generally made from an inexpensive timber plank. These are joined to form a required mold for the slab, beam, column, and the foundation. Steel formwork is used in the form of the plates, which can be bolted together to form a mold of a different shapes and the size according to the dimension of the structure's member. Formwork consists of two main parts like mold or platform and supporting system or centering or shuttering. The mold or platform is built by joining the plank together by the nailing. The gaps between the planks are sealed so that the cement slurry should not leak through them. The supporting system or centering or shuttering is made up of timber poles supporting the mold at a various point. For large slab, the formwork is supported on the timber poles with a double wedge arrangement at the lower end, so that the individual poles can be lowered or raised by hammering of the wedges, and the entire plank supports of the slab can be level and made horizontal. For column, the centering consists of inclined supporting poles or the struts. This is known as the shoring. The shoring is also easily adjustable so that the plank can be made perfectly vertical. The verticality of a plank is checked by the plumb bob. Thus, for the horizontal planks, vertical poles are used, and for the incline or the vertical plank, strut of various sizes are used as the shoring. For the beam formwork, here the soffit of a beam is supported by the horizontal plank and the side are either provided along with the formwork of a slab, or if they stand along separate beam, the sides are supported by the shoring. For slab formwork, here large plank, plywood or the steel plates are used to make the platform for the slab. The platform is supported on the number of timber poles or the steel trestles, which can be easily raised or lower for purpose of the leveling. For column formwork, here the planks are built to form a vertical mold of a column and the planks are supported by the shoring. The foundation of a column is supported by the formwork in the pit duct for that purpose. For well foundation formwork, for placing a concrete in a well type foundation or for a large diameter concrete pile, a tremie is used as a formwork. The trimmy is a pipe with the large funnel on the top, and the length of the trimmy can be increased by adding a section of a pipe whenever required for the deep foundation. The lower end of a trimmy is plugged, and after boring the trimmy to the point where the concreting is to be placed, the pipe is jerked upward, which breaks the plug and concrete is released. Then slowly filling the entire well, the pipe is raised section by section till the concreting for the entire foundation is done. After the pouring the concrete in a formwork of a various sections like beam, column, slabs and the foundation, the formwork is to be removed after some time. The removal of a formwork after the concreting has set is called as the stripping of a formwork. The time for the stripping different formwork as per the Indian standard 456 2000 is given as for the wall, column and the vertical side of a beam, the formwork can be removed after 1 or 2 days of a concrete placing. For slab with props left in position, the formwork can be removed after 3 days. For beam soffit with props left in position, the formwork can be removed after 7 days. For the slab removal of the props, if the span of the slab is less than 4.5 meter, then the formwork is removed after 7 days. And if the span width is more than the 4.5 meter, then this formwork is removed after 14 days of a concrete placing. For the beam and arches removal of the props, if the span is less than 6 meter, then the formwork is removed after 14 days. And if the span is more than the 6 meter, the formwork is removed after 28 days of a concrete placing.
Everybody, welcome back to my channel. Today's topic will be formwork. What is formwork? Understanding the convention and system formwork. We will learn why system formwork is better than convention formwork with a proper data. I will first explain about the system and convention formwork. Once we understand them, we will see the difference between them. Please watch the full video, understand it. If you might have greater experience than me, if you want to add some points about this video, please mention in the comment box. And subscription is free, so please subscribe and share with your friends. So without any delay, let's get started. Simple word, the formwork which gives the shape to concrete. One second in refuse. And another definition, the formwork holds the concrete until it gets its strength, right? So this is the image of formwork, simple formwork, which is for a column. It's but stripped when concrete is like our column is got strength, right? So next we will understand the classification of formwork. The formwork classification will be, I classified, it is my knowledge. So formwork first is conventional and system. Conventional means without any proper design or anything they will use inside, like it's from a wooden or a steel or this type of formwork. In system form, in this conventional formwork, there are two types, vertical and horizontal. In system, there is one extra called climbing. This climbing formwork is like big part, so I will make a separate video for that. I will make a separate video for that so that you will understand it properly. But in this video, I cannot able to make you understand, but I will give a common idea about the climbing formworks. Okay, then again this vertical formworks are subdivided into timber systems and panel systems. Here also timber, then drop systems and table forms. I will explain each of them with the proper images and videos. Conventional formworks. I told vertical and horizontal formworks. So you can see this conventional means they will like fully wooden. Sometimes they will use the some metallic components also. So this is very simple but very time-taking procedure, and it is very cheaper than this one. So you can see, you will get the very good idea when see what is conventional formwork. You would have seen in this very site. Most of the small sites will use the conventional formworks only because it's very cheaper for them, right? Okay, you understood the vertical and horizontal. It's simple. There no need to understand like more. So in system formworks, again, I will explain for the vertical first. In vertical, there are two types, right? Timber systems and panel systems. In timber system means it is the same principle derived from the our conventional formwork. You can see here the same components you might see, but the difference here means the each component is pre-designed. We know the each component's strength, we know each component's capacity, everything, so that it is very helpful for the designer when he designs any particular formwork. You can see if a designer is doing this formwork design, he has to mention this formwork distance between these vertical timber beams, the wailers, the push-pull props, everything, because he knows the property of that. So this one is like erection is faster than our conventional formwork, but still it is safer and stronger, and its repeatability is very more. The technical terms I will discuss in the last of the video, because once you understand, it is easy to grab the technical things easier. So this was timber. Then panel means same concept, but they are using the ribs of the metals. It might be steel or aluminium, depends. So here what happens is, see, in timber beams, you have to like erect it individually. One timber beam, second timber beam, third timber beam, one you erect it, then again you have to join it. But in panel system, it is like a pre-designed one, and it is like fixed. Just place a panel, put a tie rod, and the system is ready for like the concrete is ready to pour, like that system it is. So no that much of time required. It is very faster, and it is little bit costlier than these timber systems. Here also they have maximum capacity, like some of them have might be 80 kilonewton capacity, 60 kilonewton capacity. If your concrete pressure is about 50 kilonewton, you can aramsey use this one. If your concrete capacity is around 120 kilonewton per concrete pressure is a 120 kilonewton per meter square, then you cannot use. If its strength is 80 kilonewton per, then you have to modify this timber system, and you have to again design it. Then you can modify, and you will achieve this 120 square meter strength, 120 kilonewton per square meter strength easily. Now we'll see horizontal or slab formwork. In these three types: timber systems, drop systems, and table forms. These timber systems and table forms are similar. You can see here it's a similar, but one major difference is means, like in the table forms, what we can see is each component, like the secondary beam, primary beams are fixed, right? And this primary beam is fixed to this prop. So that you might understand your common dining table. It is like that only. You cannot dismantle it, right? This once the design is done, it is fixed. Here also it is fixed. It is used entirely from your basement to the top level of your building. This is table form. But if you listen these timber systems, timber system means it is not at all fixed. It's only here we can see this primary beam is fixed with this one. But also we can dismantle it. When in the dismantling of formwork, here we will individually like remove each part, then gather to the one, we'll uplift to the another floor, again we'll erect it, or we will assemble it, right, in the timber systems. But in table forms, no, directly we will take this, lower the props here, then we will take to the next floor, then we will rise to the required height, then we will pour the concrete. So this is table forms. Name also just tables means anybody can understand, right? But now this is one thing, sorry, drop system, right? You will ask what is drop system? Drop system means this is same panels, nothing but same as a panel formwork, but here nothing but it's laid horizontally for the slab. But the problem, it's one good definition of one good advantages of this drop system. What means you can retrieve your panels without removing your props. Are you understanding it? I will show a video how we will retrieve these panels without retrieving this one, like props. The props will be same. Props will be there, and we can remove the panels, and we will shift to the next floor. And we should give the two sets of props, so that what happens is your time of constructions will very less. Your This prop acts as a supplementary support for your slab, because I will tell, if slab is 6 meter and if you're removing the prop, it might bend, it might buckle, or it might fail, right? So we need some supplementary props until 14 days or the 28 days. It depends on your span and structure. So this system helps you to retain the panels, and we can shift to the next floor and we can start erecting the formworks. Until that, this will get the strength and we can pour the concrete. After that pouring is done, we can remove this prop and we'll shift to the next one. I will show the video and you can understand. So next is system formworks. It's like a climbing formwork. In that two I put crane climbing and self climbing. I won't explain very deeply in this one, but you can understand self like climbing formworks means if you have symmetry of outer periphery wall or something, so you want to construct it up to 15, 20, 25. It's like limitless. You can construct it using this climbing formworks. Self climbing and crane climbing difference means this is lifted by crane and it is lifted by a pump. Pump is a hydraulic pump with a suitable capacity, which is lifted once the concrete gets the strength. You can see here, this is the coning of the climbing systems. I will explain you in the next video